Hello, this is Ms. DB. In this video we are going to talk about linear functions. So we certainly can't say everything there is to know about linear functions in just one assignment or one video, but we're just going to kind of hit the highlights here. So a linear function is a straight line when you graph it. It'll have an x-intercept and a y-intercept. It will have a constant slope, so the change is constant in a linear function. We can find the x and y intercepts with algebra. We can find them with graphs as well, but it's easy to find them with algebra. All you do to find the x-intercept is to replace y with 0. So here we go, we replaced y with 0, and then we solve what we have left. So this simplifies to 3x equals 12. Divide both sides by 3, and the x-intercept is 4 for this line. And to find the y-intercept, you replace x with 0 and then simplify what's left. So negative 2y equals 12, and divide by negative 2, and we get y is negative 6. So if we are going to graph that on an xy axis, the x-intercept is 4. You could put a point there. You could put another point at the y-intercept, 1, 2, 3, 4, 5, negative 6 would be here. And then you can draw a line through those points and connect them. That's a good way to draw the graph of a line. So for your assignment, you're going to practice finding the x and y intercepts of some equations. These are written in standard form. Standard form of a line is something times x plus something times by, or something times y equals c. So that's the standard form. And standard form is really good for finding intercepts. It's not as good for graphing a line, although if you find the intercepts you can graph a line fairly well. But a lot of times we like to use slope-intercept form in order to graph a line. That probably looks familiar to you. And in this form we have the slope is multiplied by the x, and then we also see the y-intercept within the slope-intercept form. So that's super handy for graphing lines too. If an equation is not in slope-intercept form, all you need to do is solve the equation for y, and then it'll be in slope-intercept form. So you can use your algebra skills to do that. So for these 4, 5, and 6, you are going to plot these functions on a graph. You can graph them using technology if you want, or you can go ahead and use your word tools to graph them on this. You can put all 3 of them on here as long as you label them. So let's go over again how you would graph a line using slope-intercept form. This is the slope right here, and this is the y-intercept. So we start by putting the y-intercept on. So I go to the y-axis and go up 1, 2, 3, 4, 5, and there is my y-intercept. And the slope is 2, but we like slope to be a fraction, so rise over run, so I would write that as 2 over 1. And then from the point we already graphed the y-intercept, we go up 2 for the rise and over 1 for the run. And I can do that a couple times to make it a little easier to see what's going to happen. And you can even go down 2 into the left one to get another point over there. And once you have as many points as you think you need, you really only need 2 or 3. I'm just going to insert a line here instead of trying to draw it freehand. Then you would take the line tool, and mine's a little bit off. Try to insert shapes and then pick the line tool, and then you can draw through your points. And then I said you should label this, so then you could just write that this is, number 4, or you could write the equation of the line if you prefer. 2x plus 5. Or you can label it with, you can put a text box and put number 4. Or you could use different colors and then say over here what color they are. Okay, now that we have the line, we're going to say what the domain is, what the range is, and what the x and y intercept are. So the domain is all real numbers. Almost all linear functions will have a domain of all real numbers. And the range is also all real numbers. And the reason that they are all real numbers is because on a linear function, x can be any number. It can be positive numbers, it can be negative numbers, it can be 0, it can be any numbers. So that's all real numbers. And if you're putting all real numbers into the equation for x, you can get any numbers out. You can get negative numbers for y, you can get positive numbers for y, you can get 0 for y. So then the domain and range are both all real numbers. It'll be that way for all linear functions, unless you have a word problem and it's something like, you know, Tony gets paid 12 bucks an hour, and how much does he make after 5 hours, and you want to write an equation. That would be time, which is not negative, so we wouldn't use negative values on the x-axis. And it would also be talking about, you know, he's getting paid money, so you hopefully would not have negative amounts that he'd be being paid. Let's also say what the x-intercept and y-intercept are. On here, I can't tell what the x-intercept is, but I can tell the y-intercept because it's 5. So the y-intercept is 5. Let's find the x-intercept. Let's put 5 in for the y-intercept, so 5 equals 2x plus 5. And let's find the exact x-intercept because I can't really tell what it is for my graph. And it might be because my graph wasn't perfect. But if I plug this in, it says that my x-intercept is 0, which does not seem like it would be 0, so I'm looking to see if I made a mistake here. Oh, I'm sorry. I was solving something else. Instead, I should have been replacing the x-intercept is when y is 0, so I should have put 0 equals 2x plus 5. Let me erase this. And then subtract 5 from both sides. This is going to work much better. So then we would have, oops, I still have my eraser turned on. Divide both sides by 2. Yes, that's the same as negative 2.5. That does look like where my line was crossing the x-axis. So it's at negative 2.5 or negative 2.5 is my x-intercept. Okay, and then you have a couple real-world problems to solve with your linear functions. The first one is at the airport. You can change your money from dollars to euros. This service costs $5, and for each additional dollar you get 0.7 euros. So you're going to write a linear equation for the situation, make a table, pick some different values for x, plot it on a graph, and then answer a question. I'll help you set up the equation for this and maybe start the table. So we want to use, let's use y for our total cost, and let's use x for the dollars that you're going to be putting in. Alright, so our total cost is going to equal, it costs $5, so we have to add that to the 0.7 for every dollar. For every dollar you get 0.7 euros. So this is your equation. And now we are going to use that equation. I'm going to write it down here again so I don't forget what it is. You could write 0.7d, or I should say x, huh? You could write 0.7x plus 5 if you prefer. And now we're going to pick different values of x. We can pick 1, 2, 4, and let's say 8. So I'm going to pick 1, 2, 4, 8, and I could pick 10. That's probably enough. And then I'm going to plug them into the equation and see what I get for y. So at 1, I would have 5 plus 0.7 times 1, and that's 0.7, so 5.7. We can use a calculator for if they get a little trickier. So let's do 5 plus 0.7 times 2. I'll do the 0.7, whoops, 0.7 times 2 is 1.4, and then add 5, and I get 6.4, and 0.7 times 4, and then add 5 to that, and then I decided to jump up to a little bit bigger one, so 0.7 times 8 plus 5 is 10.6. And when we plot these, they should be in a straight line. If they're not in a straight line, there's a mistake because you have to get a straight line when you have a linear function. So 0.7 times 10 is 7 plus 5 is 12. Okay, so when I graph these, I'll just go over 1 and up 5.7, so 1, 2, 3, 4, 5, 6, 7. I'm not going to have a whole lot of room here, am I? That's okay. So 1, 2, 3, 4, 5 here, and at 10 I'm at 12, and I'll do one more. 8, I'm at 10.6. So you get the idea that the line would go through there. Now in this graph, or this situation, it doesn't make sense to include the negatives because we are not going to have negative amounts of dollars that will be changing, and we won't have a total of negative. So I would only need the positives for this one, and it would continue in this direction. And then there's another question to answer about determine how many euros you would get if you give the exchange office $50. So you would put 50 in for your x value and see what you get for y value. Now you wouldn't be able to graph that on this graph because it won't fit. And then there's one more question to do with a linear situation. So let me know if you have any questions, and have a great day.